Hello. Hi guys, good morning. Welcome back to a new video. Ki hal chal? I hope you guys are doing good. In this, we're gonna see a problem: maximum absolute sum of any sub array. Now, the word itself says we have to find the sum that should be absolute and taking the maximum for what a sub array. Technically, we have seen similar problem yesterday as well, which is this one. If you don't know, please go and check out here. And again, you can practice more such problems here as well. Now, coming on back, it's simply saying the same thing, that taking a subarray and taking the absolute sum of that specific subarray, find the maximum absolute sum again of any possible empty, and again possibly empty also. A subarray can be empty as well. Now again, they have resulted. What absolute means: absolute is whatever value is inside, it becomes positive. So if I have, let's say, minus 30, absolute will become 30. If I have 40, it will become 40. So it will become positive no matter what. So ultimately, as we know, a simple normal technique, if I try brute force, it can be O of n cube, taking a subarray and then from that specific subarray taking the sum of that, right? So making a subarray O of n square and taking a sum O of n. And if we want to optimize, we can optimize that to a normal n square, which is while building the subarray, we just tend to take the sum parallelly. Again, I'll not discuss here simple approaches. We have already discussed quite a lot of times in easy problems as well, right? Coming on back. So what to do? Obviously, constraint says n is large, 1e5. So I have to do it in O of n log n or O of n. Whenever I hear the word subarray sum, the first thing strikes is prefix sums. So I'll use the same thing. I'll use the prefix sum technique. Prefix sum technique says what? So I have array 1, minus 3, 2, 3 and minus 4. Prefix sum array says that, okay, maintain a prefix sum as an array, which is 0, 1, 1 plus minus 3 is minus 2, minus 2 plus 2 is 0, 0 plus 3 is 3, 3 minus 4 is minus 1. So when I have got the prefix sum array, now if anyone asks me, Aryan, find me the range L to R. So this is L, let's say this is R. Or let's say for your simplicity, let's say this is the range L to R. So this is L, this is R. Anyone finds me, or anyone asks me, what is the sum? What is the sum of this range? I can simply say the sum of this range is prefix sum of R, which is this value, minus prefix sum of L minus 1, which is this value, minus prefix sum of L minus 1. So I'll get minus, this is value of 1. So I'll get 2. And you can see that the range sum for L to R is 2 itself. Again, it's a very standard technique used for range sums. So I know I can do a prefix sums. But technically this is, do I require a sum? No. I require my sum to be maximum. Again, I will come on to absolute, but I need it maximum. So, which means I am saying that prefix sum of R minus prefix sum of L should be as large as possible. How is it possible to have it as large as possible? Obviously, I am subtracting a number. So subtracting a number should be as minimum as possible. And the number which is here should be as large as possible. So what I will do, obviously, let's say if I am, simply as we did yesterday as well. Yesterday, if you don't know, we did in this problem number of subarrays with odd sum. You can write the problem number or name here. You can find the same article. And again, this is exactly same what we did yesterday as well, that we will simply try to go on to all the indexes. Now, if I am on a specific index, which means my prefix sum of R is fixed. Let's say prefix sum of R is fixed here. If the prefix sum of R is fixed, technically I will say, okay, get me the minimum prefix sum of L, which means in this entire portion, whatever is the most minimum value of my prefix sum, which is minus 2, will give me the maximum result currently for this 3. So this is 3, which is fixed. I'll subtract what? I'll subtract the minimum value, most minimum value, which is minus 2. I had seen previously as the most minimum. I'll put it here, minus 2, and thus I'll get a value of 5, which is technically for this 3 being somewhere, minus 2. So this range is the maximum. Again, obviously, I will have to end. My R will end at the index I, but I will get this specific answer as the maximum sum. So again, it's a simple math, right? Okay, you have two numbers and you are subtracting them. You want the result to be as maximum as possible. You will want that this number is as minimum and this number is as large. Now, this is what we discussed when we are saying, okay, we are taking the maximum sum. But what about this absolute thing? Okay, no worries. The absolute thing will help us to figure out what exactly can we do in case of a negative number. For example, let's come on back, which means that if I'm standing here, right, my I is here, my this number is negative. So let's come on to this portion. Now I'm saying that my, again, the maqsad or the target remains still same. I want the result to be as high as possible. Now the only catch is that whatever value comes here, I can make that as entirely positive, which means I can take that as absolute, which will make it as entire positive, which means that now I would try to have this thing as negative as possible, as large negative as possible, and that large negative, when I will do it positive because of absolute, will become as large as possible, which is what I want. So if my current index, if I am at I, my value is -2, my value is -2, then I have to subtract something, right? Again, earlier I was subtracting with the minimum value, but now I want it to be as large negative. So I will subtract with the largest value, with the largest value. And I see in the previous, the largest value is 1. Okay, if I subtract with a 1, obviously I'll get the negative result as -3. And now, because it is as large negative as possible, I will take the positive, which is absolute of this. It will become positive and it will become a 3 again, which indicates that -3 is the corresponding range sum, which is very large, because why? I can take absolute of that as well. That is how I can go about it. So in summary, what we realized is that we have two numbers and we have to get their sum as large as possible. Now, there can be two possibilities. Obviously I can either subtract, for whatever the current prefix sum is, whenever I say current prefix sum, just imagine I am moving in from left to right on that specific prefix sum array. So whatever is the current prefix sum, no matter what, I will try one thing: subtract with the minimum prefix sum. I will maintain, I can simply maintain the minimum prefix sum so far and maximum prefix sum so far. So from the current prefix sum, either I can subtract the minimum prefix sum, and again, it's your wish to take absolute at every point in time, because obviously I have to take the absolute no matter what, because again, if the current prefix sum itself is, let's say low, let's say number 2, but minimum prefix sum so far is, let's say, very high, let's say it's 4, but still, like, the value will be -2, but I should make sure that I should take absolute at every point in time. So yeah, absolute is something which you can add it as a salt. Now there's another case, as we discussed previously, that we will have one more case, in that if I have, my current prefix sum, again, this current prefix sum is based on, I'm moving on the index, and I will put up here maximum prefix sum value, and again take the absolute of this, and that's gonna be my answer. So whatever out of, again, I will try for both the possibilities, right? I will try for both the possibilities, but whatever give me, again, and I'll just maximize my answer, or I'll say have another variable, maximum absolute sum. This is what I will maximize, and will give you the answer. So this is exactly you have to do as well. Cool, let's do a very quick dry run, and let's see that how we will go about it. So let's do a dry run with this example only, this one. So let me quickly copy this. Okay, my tablet never works. Yeah, now if I just quickly copy this and come down, again, you got the idea, right? That the idea is simply taking up maximum and minimum so far and thus maintaining it. So I will maintain, okay, my maximum sum, it is maximum prefix sum so far is 0, minimum sum, let's say, is 0 itself, and again, I just keep on minimizing it and maximizing it based on my current sum, which is, I will say, current prefix sum. again, you don't want to build this array, as again this is a kind of optimization which you can do after in an interview as well, but this is the same optimization which we did in the previous question, which is our number of sub array sums with odd sum. If you don't remember, the optimization was that if you remember in the approach, in the normal approach, where is approach 2? Yeah, in the normal approach we were building up the actual array, but then we realized we just need a variable, prefix sum variable, and thus we took only the prefix sum variable itself. So here also we'll do the same thing. We just make sure that I use a prefix sum variable, or again in the code I have referred as the current sum. So that also you can say current sum variable. In the very beginning, you know it is 0. Now let's start the fun part. The fun part says that okay, my current sum will actually become a 1. Now 1, and again I will just try to maximize my sum. So I will have a maximum absolute sum that will be maximum of existing value, so which is maximum absolute sum, or as I told you, two option is absolute of whatever the current sum is, and I will subtract it with the minimum sum, or another is absolute of whatever the current sum is and subtracting with the maximum sum. And that is how I can just try for both the possibilities. Now let's try to have this, and we can just simply break this entire portion here so that it's easy for you to see the dry run parallelly. Now, so okay, in the very beginning my current sum is 1. I will try to subtract with the maximum and minimum, both are 0. So far my maximum answer will be 1. Okay, 1 minus 3 will be minus 2. So now my current sum is minus 2. I'll subtract again. Obviously, I will have to maximize my maximum sum and minimize my minimum, which is 0 itself. So for this range, it is 0 minimum. So for minus 2, I will try the first option is minimum sum, which is 0. I'll get a minus 2. So obviously it is maximized already. And then minus 2 minus the maximum sum is 1, minus 1. So it is minus 3. So yeah, why not? I should take a minus 3. So I'll take a minus 3. And again, doing absolute of minus 3 will become a 3. Okay. So now this is gone. Let's proceed forward. Before proceeding forward, updated. So this will become a minus 2, and 1 will remain 1 because this is the corresponding maximum prefix sum so far. Then minus 2 plus 2 is 0. So I will say 0 minus minimum sum so far, which is minus 2. So it will become a plus 2. So this will be 2, but not maximizing it. Okay, then 0 minus this maximum sum is 1 so far, so it will be minus 1, positive plus 1. Still, it will not impact, and let's proceed forward. Maximizing it, not impact. Okay, proceed forward. 0 plus 1, which is 3. I'll get 3 here minus minimum sum, which is minus 2. So I'll add plus 2, will become, it will become plus 2. This will become 5. Obviously, it will maximize, so it will become 5. And then obviously I have 3, which is this case, subtracting with the maximum sum is 1, it will become 2. Okay, I obviously have 5, so skip it. Now before proceeding forward, maximum sum will become 3 and minimum sum will remain as is. Now 3 minus 4 will become minus 1. I am doing a correct thing now. Minus 1, and then I'll say minus 1 minus of minimum sum value, which is minus 2, it will become plus 2. So this will become a plus 1, not maximizing it. Then another option is minus 1 minus of maximum sum value, which is minus 3, it will become minus 4. Again, 5 is already maximum. So technically I should give my answer as 5, and that's my answer. Cool, and that is how you can simply go about it. Let's see the code. It's exactly same as what we saw, that I will have minimum sum, maximum sum, current sum, which is the prefix sum, and the maximum absolute sum, which is the answer. Now I'll go on to all the numbers. I'll make sure, again, I could have used the prefix sum array as well, but we had already seen in the previous optimizations that we can maintain the prefix sum as a variable. So I have to run the same thing. I have maintained the prefix sum as a variable. Now here the prefix sum, I just added that with the current value of num. Now I just went ahead and maximize my maximum absolute sum, which is option 1, taking current sum minus the minimum sum, or option 2, taking the current sum minus the maximum sum. And thus when these two are maximizing my answer, then I am going ahead with the remaining stuff. What is the remaining stuff? Obviously making sure to minimize the minimum sum, maximize the maximum sum, because this will be helpful in future. And this is how we can go about it. Again, time will be simply O of n. one pass, everything is so simple, so smooth, so cute, and space will be over fun. Now, just as an extra sprinkle, again, just a fancy stuff which you will see that we can technically eliminate this line. Why eliminate this line? Because, and again, if you say eliminate this line, then you might ask Aryan what to return then here. Obviously, in that case, if we see very carefully what we were doing, we were trying to get this thing that I have two numbers and I want the maximum value, right? I want this thing to be as high as possible. For that, I was saying, okay, if this, whatever this value is, which means I'm going on to all the indexes, so I know the current sum, I'll just try to keep, because it's negative, I'll try to keep it minimum. Or then I said that I'll try to keep maximum, because obviously this will become negative. So obviously, if this thing is low, I'll keep it very high positive. This will become entirely negative, and thus obviously absolute will make it large. Now, if you see very carefully, technically you're maintaining this prefix sum, right? And in the end, you want one thing. You want just one thing. What is that one thing? One thing is large value or large sum. So can't I simply say that here I can place, again, obviously, if you see that you are placing current sum and either the minimum sum or the maximum sum. This is what you are placing, right? Now, if I look at it without the absolute, again, I'm saying without the absolute, if I look at it, can't I simply place here the maximum value possible, the maximum value possible, and then I will simply place here the minimum value possible, minimum value possible. Now, you might ask or you might argue with me, but Aryan, technically, if you remember, the rule of range sum says it should be prefix sum of R minus prefix sum of L minus 1, right? In that case, it is not, again, the range sum does not say it is prefix sum of L minus 1 minus prefix sum of R. It does not say this. It does not say this. But I will say yes, it says this for this problem. Why? Because I am taking the absolute. I am taking the absolute. So technically absolute of both these are same. So for me, it doesn't matter. For me, it doesn't matter if prefix sum of R is large or L minus 1 is large. I just want one thing to be as large as possible, another thing to be as low as possible. I will subtract them. And again, I don't want to take absolute right now. Like, I don't want to take absolute because I have already handled it while I was saying that one is very large, another is very low. So again, I don't care if prefix sum of R is very large or L minus 1 is very large. No, I just want, okay, one of them will be large, one of them should be low. Now, which one? I don't care, because obviously I will take absolute. So whatever will be large will come on the left side, whatever will be low will come on the right side. And thus I can simply place by saying, okay, take the maximum prefix sum here, minimum prefix sum value here. So I will simply go and say here that, just removing this line, again, I can remove this variable as well. But again, no, sorry, not this, but this variable as well. Then I can simply say, take the maximum sum minus the minimum sum, maximum sum minus the minimum sum, and that's the answer. If I just show you the try run for this, it will be maximum sum minus minimum sum. So 3 minus minus 2, and that's the 5, which is answer. Did you see the hint? The hint is that because these two equations are now same, so whatever is large, I don't care. Either it is prefix sum of R is large or prefix sum of L minus 1 is large. No, I don't care. If prefix sum of L minus 1 is large, okay, this will come here and it will become prefix sum of L minus 1 minus prefix sum of R. So both are valid. So technically both are valid here. Both of these are valid, and because both being valid, I will just have to simply replace by saying one being higher, another being lower. That's it. I don't care which one, and that's how I can simply solve it. I hope you guys got it. Again, just it's a fancy way. I'll say not again, like nothing changed. Time, space, here also time is still same and space is also still same. Nothing changed. It's just another fancy way just to, people say or could say it. But yeah, that's what it is. I hope you guys liked it. If yes, please select the, let's complete the like target of 100 likes, and make sure that you check out the practice problem sheet. Again, it's a bit of practice only. If you want to check out the actual problems, go and check out the DSA sheets. It's pretty concise, short, sweet, and based on what is being asked. Bye bye.